Guys, last section of the year. Last video you ever have to watch for me. So 12.7 here is just similar solids. So it's just like the last section of chapter 11. All right, we're going to use the scale factor as similar solids to find the ratio of the surface areas and the volumes. Okay, so first, similar solids, what are they? They're just like similar polygons or similar triangles or any of that stuff. Okay, we've got the exact same shape, different size. Okay. So all the angles are going to be the exact same. They're all going to be congruent, and we're going to have proportional side lengths. So anything in one dimension, anything that's a line segment, has to be proportional. So heights, radii, slant heights, diameters, base edges, lateral edges, all that stuff have to be similar. Okay. So this theorem is going to be very similar to the last one, right? Scale factor is just A over B. If you're going to work with areas, so this is anything in one dimension, okay? Any line segments, A over B, right? Just a line. Now, if you make it two dimensions, for example, an area, right? An area is a flat two-dimensional space. It's going to be A squared over B squared. We've already learned that back with ratio of areas last section. Now, if you go to a third dimension, if you're going into space, right? Three-dimensional types things like volume, it's going to be A cubed over B cubed, right? So you don't actually have to find all these things. You could just work with the ratios, squaring them and cubing them to find all of them. So I'll show you what it looks like in examples. First thing we're going to do is try to figure out, are these similar? Okay, are they similar? Well, how are you going to figure that out? You got to make sure that they're all proportional. So the corresponding sides have to be not congruent, but they have to be proportional. So 3 over 4.5, right? These are also with each other, equals 5 over 7.5 equals 4 over 6. All right, so if you reduce all of these, they should all come out the same thing. All right, well, you reduce this first one. It reduced to 2/3. Second one, 2/3. Third one, 2/3. All work. They are similar. Okay. Now with that, since we know similar solids, we have the scale factor, right? The scale factor is obviously 2/3. So since the scale factor is 2/3, the ratio of areas is going to be A squared over B squared, so 4 over 9. And the ratio of volumes is going to be A cubed over B cubed. 2 cubed is 8. 3 cubed is 27. So that will be our ratios. Okay, and number 2, I tell you you've got rectangular prisms that are similar. I give you the scale factor of 1 to 4. You're going to find the surface area and the volume of prism B if I tell you the surface area and volume of prism A. Okay, so if the scale factor A over B is 1 over 4, then we should know that A squared over B squared, which is the ratio of the areas, is 1 over 16, and A cubed over B cubed is 1 over 64. Okay, so we can use these ratios to help us create a proportion to solve for our volume and our surface area. Okay, so the surface area is going to use the ratio of areas. So 1 over 16 has to be equal to 28, right, because that's the A, right? A is 28 over surface area B. Cross multiply and divide. Then we get B equals 16 times 28, which is 448. So B equals 448 square feet. That's the surface area of it. Now for the volumes, we're just going to use 1 over 64 equals 8 over volume of B. Okay, because A, prism A is 8 feet, so that's why it's going on top. So once again, cross multiply and divide. We don't need to worry about dividing because 1 times V is V. Okay, so we've got 64 times 8 is 512 cubic feet. Right? Now, number 3, I'm going to ask you to work backwards. So I'm going to tell you the volumes of our cubes. We've got 2 volumes of 64 and 1,000. Okay? So that's like A cubed over B cubed, right? Because we're working with volumes. Okay? We want to find the the scale factor of that. So if that's a cubed over b cubed, how can we translate that to a over b? Well, we need to take the cube root of both sides. So we can take the cube root of everything. All right, so a over b, well, let's move this over a little bit. So a over b is going to be equal to the cube root of 64 over the cube root of 1,000. Okay, so the cube root of 64, the way that you do this is you hit math on your calculator, scroll down to the fourth one down, you see the cube root button, 64, enter, and it is 4. So a over b equals 4. Do the same thing for 1,000, and you get 10. So 4/10 is going to be our scale factor, or 2/5 if you reduce it. Okay, and the next problem. We get two similar punch bowls have a scale factor of 4 to 5. The amount of concentrate to be added is proportional to the volume. Okay, how much concentrate does the smaller bowl require if the larger bowl requires 32 ounces? Okay, so we're going to be working with, obviously, volume here. It tells you we're proportional to the volume. So the smaller one, so we have 4 to 5, right? But we want 4 cubed over 5 cubed because we are working with volume. So you can type that in your calculator, 4 cubed, 4 to the third power is 64. 5 to the third power is 125. So 64 over 125 is equal to the smaller bowl, we don't know, that's our x. The larger bowl is 32. Okay, so we cross multiply and divide, and we have 125, right? We need to multiply those together, So we have 125x equals 32 times 64, 2048. Divide both sides by 125, and x equals 16.4 ounces. Okay, and very last problem. Two similar cones have surface areas of 384 pi and 216 pi square feet. There should be a pi there. Find the scale factor by finding the ratio of the surface areas. So we can find the ratio of these surface areas, 348 pi over 216 pi. Right? The pi's don't matter, they cancel each other out. We can reduce that as much as we possibly can. 348 over 216, you can type in your calculator. This is a nice little hint. So if you type 348 over 216 in your calculator, you should get 1.61111 lots of times. Okay. Once you get that decimal, you can turn that into a reduced fraction by hitting math, enter, which it should be an arrow to fraction. It means it's turning into a fraction. Hit enter again, and we get 29 over 18. So that's the ratio of the areas, a squared over b squared. Well, we want a over b. So that means that in order to get a over b, we have to take the square root of both of them. Square root of 29 over square root of 18. Okay, so that looks pretty good. And that's the final answer. That's scale factor.